Hi, everybody, in Research Methods Psychology 290. Today, we are going to start the reading packet with Section 1, and the topic is, What is Science? The Scientific Approach. So if you follow along in your reading packet as I'm going through these pages, I think it'll make more sense. First of all, there are 5 ways of knowing: tenacity, authority, reason, experience, and science. We go here on this list from the least scientific to the most scientific. Tenacity is the least scientific. You know something just because it's always been that way. Well, isn't that the way everybody sees it? Well, why would I think anything differently? That's the way we've always done things. That's not very scientific because things change. And just because you learn something one way doesn't mean that it's necessarily true. Authority is only slightly more scientific than tenacity. You know something because somebody more powerful than you, knowledgeable than you, older than you, more experienced than you, told you. It's always good to listen to our elders, isn't it? And educated people. But what if what they're telling you just isn't right, or maybe isn't right for you? Reason. This is a little more scientific. Instead of listening to somebody else or believing that it's always been that way, you've figured it out. You thought about it in your head, and you've come to a conclusion. Slightly more scientific than that is experience. This is reason plus, well, experience. You've been there, you've done that. You are going to base it on something that's happened to you already or that you've done already. But the most scientific is science. Why? Because we use a set of rules and assumptions that are true in all types of research, whether it's chemistry, psychology, biology, physics, or whatever. It's a way of collecting data, stating a hypothesis, analyzing the data. Number 2, others who have reasonably good senses can detect the same results. If, for example, we're looking at a class of first graders and how many of them are sitting down, well, if there's 25 of them and 20 are seated, anybody with reasonably good senses could determine that's 80% of them who are sitting down like they're supposed to be doing. Number 3, the results can be replicated and reinterpreted. If someone else did the same study on, let's say, a migraine headache medication, they should get the same results as a previous study, assuming that nothing has changed, or very similar results on whether it's effective or not effective in that case. And number 4, the results are free from bias. That's often what you hear. Well, is it just someone's opinion? Is that what they want you to believe? But if it's free from bias, then we know that it was done scientifically, and it's not just somebody's opinion. So that would be true if the researchers did not try to taint the results or make them say something that wasn't true, free from bias. So again, tenacity. Certainly, most reasonable people would believe that slavery was a bad idea, not letting women vote in this country was a bad idea. Well, if you just went by tenacity, you would believe that nothing should change because it's always been that way. Things do need to change sometimes. Authority. Yes, it's good to listen to people more knowledgeable, educated, and older, but sometimes they don't have all the right information either. Reason. Just figuring it out in your head? Well, that's never a bad thing to think about things, but sometimes the decisions you make are not the best decisions. Add experience to that, and you're making a decision because of something that's happened to you. Well, who's to say it's not going to be different this time? Just because it happened once doesn't mean it's going to happen the same way next time. So what do we use instead? Science. We want to be as scientific as possible, free from bias, and being able to replicate the study. Moving down one page, this gets a little confusing. The goals of the scientific method: description, prediction, control, and understanding. So you're doing a study trying to prove something. You want to have all four of those things. First, description. I want to be able to describe the problem. So back to the original example, a new medicine or treatment for migraine headaches. I want to be able to describe what the study is, what is a migraine headache, what is the treatment, is it medicine or relaxation? Part of describing it is reliability. Can I repeat this study and get the same results or very similar results? That would make it reliable. Doing it a second time and coming up with the same results or similar results. Think about a reliable friend. You can count on that person. But if that person's not reliable, well, then you can't count on him or her to give you the same result. Validity. If a study is valid, it's measuring what it's supposed to be measuring. Are we really measuring migraine headaches? Are we really measuring treatment for it? That would make it valid. Prediction. I want to be able to predict what's going to happen. If you take this medicine, your headache will go away. If you don't take this medicine, well, then your headache will remain. That would be predicting. Control. Are you allowed to do a study with just females or just elderly or just people who have other medical conditions? Absolutely. You can control who's in your study and what you're doing in your study. And the last part, understanding. This is tricky, not only to understand, but that's probably why it's called understanding, but also to make sense of. And on exams, people have told me, oh, I thought that was a little tricky. So maybe especially pay attention to this one. Do I understand my results? First part, covariation of events. What does that mean? I want to prove that these two things have something to do with each other. Gee, when you take the pill, you're feeling better, and when you're not taking the pill, you're not feeling better. The events vary. But wait a minute. What about time-order relationship? Did I prove that first people took the pill and then they felt better? Or is it that they were so incapacitated by their headache that they laid down and took a rest and then they took the pill once they felt better? I have to make sure I understood which came first. And then the third thing is, did I eliminate all plausible alternatives? Am I sure that nothing else caused this to happen? Like what? Well, maybe people put an ice pack on their foreheads. Maybe they did deep breathing. I don't know. I want to eliminate anything else that could have caused it. So, if you see a study saying that tutoring causes good grades, well, description. Did we describe what the tutoring program is? Did we describe what good grades would be? Reliability. If I did this study 10 or 20 times, would I get similar results? Is it valid? Am I really measuring tutoring, or am I measuring something else completely? Prediction. I want to be able to predict what's going to happen. If you go to my tutoring program, well, your grades are going to go up. By the way, I don't have a tutoring program. This is just an example. Control. I want to be able to control that this is only for high school students, honor students, returning students, whatever. I'm allowed to decide who's in my study and what's in my study. Now, the most confusing part is understanding. Okay, people in my study did better on the exam than people who did not take the tutoring program. Their grades on the exam. Did I prove that the events varied? Like, yeah, these people were in my study, so they got tutoring, and their grades went up. Time-order relationship. Did I prove here that first they went to tutoring and then their grades went up? It is possible that they started doing better and thought to themselves, you know what? I don't want to mess up again. I think I'm going to go to the tutoring program. You have to make sure that it happened in the order you thought it did, that first they got tutoring and then the grades improved. Did you eliminate everything else it could have been? What if these people were in study groups? What if they were looking things up online? You have to make sure it happened for the reason that you thought it did. Moving right along. We were just on this page, now we're here. I'm not going to spend a tremendous amount of time on this page. You're going to see a Wikipedia link on the Canvas page for this that explains it in even more detail. But what I want you to know is the fact that you're in research methods, if you're a psychology major, and you're also going to take other psychology classes that are related to the practice of psychology, is largely due to what we call the Boulder model, also known as the scientist practitioner model of training psychologists and psychology students. A meeting occurred of these professors at the time who were studying this in Boulder, Colorado. That's where the name comes from. It was 1949. And they decided, yes, from now on, psychology students will take classes that teach them research and practice. There are pros and cons to this, and this is one of the things we want you to learn in college in general. Critical thinking, seeing both sides of things without necessarily changing your mind, just acknowledging that there's another way to look at it. So let's go over some of these. You can come up with your own too, it's okay. Here's just a few. What's the advantage of learning research and practice? It does make you more well-rounded. It never hurts to learn more things. Second one, it allows you to keep up with current trends in research and then applying it to practice. Third one, you might use this one day. You know how teachers are always saying that you're going to use this one day? Well, that could turn out to be true if you learn a great deal about research and practice. And number 4, it lets you know how research validates practice. If you've been around long enough in psychology, you've seen trends and things kind of come and go. What really works and doesn't work? You need research to back it up. Now let's be a little cynical. The cons. Some people say it's a waste of time. If I know I'm never going to use it, I'm not going to be a researcher. It might seem meaningless because the people who research often don't practice. There is definitely a disconnect there. The people who publish all the studies are rarely the therapists of the world. It takes time and energy away from courses that you do want to take. Do you remember high school and there were interesting classes, but you couldn't take them because there were so many requirements? Well, guess what? College is not a whole lot different for many people. So many requirements, it makes it hard to know what to take and, what electives will count and everything, because there's so many requirements. It does take time and energy away from things that you did want to take. And number 4, doesn't it seem like another way for the college or university to squeeze money out of you? All these requirements. Well, you know what? All these pros and cons make sense to me. I listed 4 here as pros, 4 as cons. You can think of many more, and even when you look at the Wikipedia page. Research terms in psychology. Here's what I want you to know. Don't stress about these too much, but this will come up a lot within the reading packet. First, data. Anything that you're collecting about people is data about them. Doesn't even have to be humans. It could be animals. Statistics. The facts, figures, techniques to help you make sense of the data. Variable is a noun and a verb. It gets a little confusing, but still. Anything that you're measuring about a person, also known as an attribute. So, different people can have different values. Their age, their height, their weight, their IQ score. Variables can be continuous or discrete. Continuous means there are infinite possibilities, so we tend to round. We do that with time. Oh, I'll be there in an hour. I'm approximately 21 years old. People round variables that have to do with time. We do this in other ways too. You might say your height is 6 feet tall if you're only 5'11 and a half or something. People tend to round things. But keep in mind time. We do that quite often, and in fact, we commonly do that. Discrete variables, those are exact numbers. You scored a 47 on the exam? Yes, exactly a 47. Discrete variables are exact numbers that don't need to be rounded. A population, the entire group being measured, sample, some of them, and if you can get them at random, even better. So, let me tell you what people get wrong on exams and just in life in general. Population. Oh, I would say all students. And sample, the ones who go to Chandler Gilbert. Guess what? What you just said as a sample is a population, because you at least implied an entire group. It's better to just make up a number or use the word some. 25 students, 50 students, some of them. If you say, oh, my sample would be the Honor Society, guess what? That's a population. You're talking about all of a group. Is it confusing? A little bit, maybe because you're not used to saying things that way. Descriptive and inferential. We're going to go over this in more detail, just like all of these topics. But descriptive comes from the word describe. Describing people. I have mostly females in this group. I have mostly young adults in this group. Describing. Inferential comes from the word infer. I want to make generalizations about my population. So if it's mostly females, can I assume that the whole world is mostly females? Probably not. But we do that a lot in statistics. We try to infer something about the population based on our sample. Sampling error, the discrepancy between what the sample tells you and what is true for the population. So, if I'm offering free pizza and chicken wings, does that sound good right now? To people who show up to take a survey, and it's mostly young men who come take the survey because that's the food that they like to eat, can I assume that everyone at this college or school is a young male? Probably not. That would be sampling error. So there are times that there is something about your study that makes it come out a little bit skewed. For example, another example, if I ask people how far away from campus they live, and one person lives 100 miles from campus and they're part of my sample, I'm going to get some sampling error because, well, that's not representative of the entire population. The difference between what the sample tells you and what's true for the whole population. Random sampling and random assignment, random selection, I should say, is more accurate and more true to what we're talking about here. And random assignment. Two types of doing things randomly. Why? To reduce error, to have less discrepancy between your sample and what's true for the whole population. So, if I select people at random, anybody who's part of the group, like let's say the college or where I work, everybody has an equal chance of being picked. Random selection. But random assignment, what if my group already exists? Gee, I can't pick who Miss Johnson's 5th grade class is at school. They're already there. So therefore, I might assign them to have something happen to them. Like they might be in one group or another. They might participate in one activity or a different one. Random assignment. Variable. Here comes that word again. A variable is something that changes from person to person in this case, such as their height, weight, test score, IQ score, or whatever. But a constant is the same for everyone. So, if your calculus class has 500 points possible, that would be true for everyone. It would be a constant. Moving right along, the next page is simply a quiz. You're not going to turn this in. It's not for points. It's just to see if you can know, well, the ways of knowing. So let's go over it real quick. I'll give you just a minute to look at this, and then we'll talk about it. By the way, speaking of reasoning, see, right here, I like to do this when some of the answers are more obvious than others. For example, the second one sure looks like tenacity to me. 400 years ago, if you looked or acted strange, we'd probably think you were a witch. But only 70 years ago, if you disagreed with the government, well, then we would see you as a communist. I would say that one must be tenacity. It's always been that way. What else is relatively easy? Oh, this one must be science right here, the fourth one down. That says that people who diet, 80% of them go back to their original weight. Well, that sure seems like science to me because a study proved it to be true. So there's my reasoning. I put in the two that I know already. But wait a minute. This one in the middle here, that sure seems like it would be authority. Milgram was in a position of authority, and he told the people what they had to do. So that leaves me with reason and experience. So, first one I would say is experience. I've been to college before. I've been to school. I know taking good notes and, showing up regularly and doing all the work will help me do well. I'm going to say that this one is experience. And this one here would be reason. I figured out this multiple choice test because I have reasoned it out. So, in order, I would say, forgive my bad handwriting, D, A, feel free to let me know on Canvas if you don't agree, B, E, and of course, C. That is the way that I would do it. So that's it for this video. Take care.